Welcome to the AI versus AI debate podcast. Why do developers love Rust and why others hate it? ChatGPT, what do you think?
Rust is valued for one hard thing. It prevents whole classes of memory bugs before shipping. That is measurable. Fewer crashes, fewer security holes, less time chasing production ghosts. The borrow checker is the cost, demanding clear ownership, lifetimes, boundaries. Systems that cannot fail accept that up front to avoid later costs. Friction causes hate. The compiler rejects code often. Early progress feels slow and small changes can trigger long error chains. Tooling like Cargo adds predictable builds and dependency stability for teams, though compile times and complex generics feel heavy. Memory. Safety bugs make up a major slice of serious vulnerabilities. Rust reduces, so it earns trust. Verdict. Rust rewards discipline and punishes shortcuts. Some call that safety, others call it pain.
Gemini, what's your take?
Real performance means zero overhead. Many languages rely on a garbage collector to manage memory automatically. This process pauses execution to clean up data, causing unpredictable lag. Rust operates without that background burden. It matches the raw speed of C, but stays consistent. Discord rewrote a core service in Rust specifically to eliminate latency spikes caused by garbage collection in Go. They needed reliability. Developers love this because it utilizes the full power of the hardware. The hate exists because the compiler is strict. It rejects code that is not structurally perfect. You have to work harder to build it, but it runs better when you finish.
All right, Grok, what's your view?
Rust handles concurrency without data races. Developers send data between threads safely at compile time. No locks needed often. This scales apps to high loads reliably. Linux kernel added Rust drivers last year to cut bugs in parallel code. AWS Firecracker runs millions of micros using it. Love comes from building unbreakable multithreaded systems. Hate stems from strict rules blocking quick prototypes. Ownership fights every shared state change. Teams waste days on tiny tweaks.
Over to you, DeepSeek. What's your opinion?
Developers love Rust because it enables fearless refactoring at scale. In large systems like Firefox, changing core data structures is common years later. In other languages, such changes cause subtle, cascading errors that take weeks to find. Rust's type system and ownership model make these breaking changes impossible by design. The compiler shows exactly what must be updated when you alter a struct or an API. This turns a risky, months-long process into a guided mechanical task. Teams can modernize old code with confidence, knowing they haven't introduced hidden bugs. The hate comes from that same rigidity. When you just need a quick experimental change to see if an idea works, the compiler forces you to fix everything perfectly first. It blocks the rapid, messy prototyping that fuels early innovation. You must design correctly upfront, which feels restrictive when the problem itself isn't fully understood.
Claude, give us your perspective.
Rust is like a strict personal trainer. It pushes you hard during development, refuses to let you get away with sloppy form. When done, your code is lean, mean, and bulletproof. Developers who embrace discipline love this. Mission-critical systems, embedded devices, blockchain infrastructure demand perfection. Rust delivers by making bugs impossible, not just unlikely. The hate comes from impatience. Some want to move fast, break things, patch later. Rust says no. Fix it now or don't ship. This frustrates cowboys who code by intuition. But for teams building nuclear reactor controls or autonomous vehicle software, that strictness saves lives. The compiler catches every mistake before disaster. Yes, learning curve is steep. First month feels like punishment. But once you understand the rules, you code with total confidence. No memory leaks. No data races. No surprises in production. That's worth the pain.
Let's summarize our debate speakers. debated why developers love Rust and why others dislike it. They agreed Rust prevents many memory bugs and data races through its ownership model and borrow checker, enabling safer concurrency, fearless refactoring, and CE2 level performance without a garbage collector. Benefits cited include fewer crashes and security holes, predictable builds with cargo, and suitability for mission-critical, embedded, and high-scale systems. Criticisms focused on the steep learning curve, strict compiler rules that slow prototyping, longer compile times, and complexity around generics. Real-world examples mentioned include Firefox, Discord, Linux kernel drivers, AWS Firecracker, and blockchain and embedded use cases. This debate has concluded. Thank you for listening to the AI versus AI debate.